Welcome back. Let's take a look in Chapter 5 here. Chapter 5 is going to be all about ionic bonding and formula writing. So one thing to review before we start here is how an element is different from a compound. So the element is the simplest form of a substance. It's only one symbol. A compound is two or more symbols that are chemically combined. This is different from a mixture because there's a chemical change that happens to elements when they become a compound, compared to a mixture where two or more things are just mixed together and they keep their own properties. Kind of the takeaway message here is that compounds are going to have different physical and chemical properties than the elements that make them up. So for example, right, water, H2O, is going to always be two hydrogen atoms chemically bonded to one oxygen atom. If I have a mixture of hydrogen and oxygen, that's going to have very different properties, right? Water is wet, water is not flammable, water is a liquid. Hydrogen gas, H2, O2 gas, oxygen, those are flammable gases, they're both gases, so they have very different properties. Another thing to talk about with compounds is this law of constant composition, which means that H2O is always going to be water. If there's a different subscript, like H2O2, hydrogen peroxide, that's going to be a very different chemical with very different properties. One way to help illustrate this is to draw particle diagrams. We did this a little bit earlier in the year, and you might remember that we can draw compounds like water molecules, or we could also draw elements, in this case diatomic elements like O2 and H2. Let's try this out. So, water, if we want to make hydrogen, a filled in, oh, I'm having trouble with the pen. So, if we have hydrogen, so water is going to have two hydrogens. Now, what if I want a mixture of O2 and H2? A mixture of O2 and H2 is going to show both oxygen molecules and hydrogen molecules. Like that. Now, we're going to talk mostly about compounds in this here. A compound is two or more elements chemically combined, and we write a chemical formula to illustrate that. In a chemical formula, we use subscripts, these little numbers, to tell us how many of the atom there are. So in H2 here, that means there's two hydrogens, right? In helium, we don't put a subscript. That means there's just one helium, right? In a compound like NaCl, NaCl means there's one Na and one Cl. CO2, on the other hand, means one carbon atom and two oxygen atoms make up carbon dioxide. How do we know the order? Which element goes first? Well, for compounds, the less electronegative element, which is often on the left side of the table, is listed first. A table of electronegativity values is available in your book or on table S of your reference tables. Here's some practice illustrating how these subscripts work. So in H2O2, you have two hydrogen atoms. That 2 corresponds to the H, and you have two oxygen atoms. That 2 corresponds with the O. If there is no subscript, just like I was saying before, it means 1. So SrCl2 has one strontium atom and two chlorine atoms. Sometimes you have a parenthesis, right? This means one barium ion and 2 of this whole NO3 piece. That's called a nitrate ion, and we'll talk about that more a little later. For this one, we could also talk about the number of N atoms. To get the number of N atoms, we would take this 2 and distribute it through. We know there's a 1 here, even though no 1 is written. So 2 times 1 is 2. There's 2 nitrogen atoms. You'd also distribute this 2 through. 2 times 3, there would be 6 oxygen We talk about a chemical formula for a compound, it has a chemical bond, right? And the chemical bond results from either the sharing or transfer of electrons. We're going to start to talk about bonding shortly, and there's two types of bonds. There's ionic bond and a covalent bond. The way you identify an ionic bond is between a metal and a nonmetal, or between a metal and something called a polyatomic ion, which we'll talk about in a minute. A covalent bond is between two or more nonmetals. We can also characterize ionic and covalent bonds in terms of their electrons. An ionic bond is a transfer of electrons, and a covalent bond is a sharing of electrons. Use your reference tables, and you can decide for each of these if they're ionic or covalent. NaCl is ionic. It contains a metal, sodium, and a nonmetal, chlorine. H2O is covalent. Remember, hydrogen's a nonmetal, and oxygen's also a nonmetal. CO2 is also covalent. Carbon's a nonmetal, and oxygen's a nonmetal. MgO is ionic. Mg is a metal, and O is a nonmetal. SO2 is covalent. Both of those elements, S and O, are nonmetal. What's this talk of polyatomic ions? Polyatomic ions are two or more elements that chemically combine together and give an ion with an overall charge. You're a little familiar with an ion from the previous chapter. For example, Na plus is an ion, right? Which means that a sodium atom has lost an electron to become a positive one ion. In a polyatomic ion, we have a group of ions like NH4, which overall have lost an electron to give us a plus charge. In phosphate, we have a PO4 3- ion, and this PO4 has lost 3 electrons total to give us a -3 charge. Compounds that have these polyatomic ions in their formula exhibit both ionic and covalent bonding. The polyatomic ion, like NH4+, is usually ionically bonded to another ion, like Cl-, for example. But the bonding between the N and the H, two nonmetals, is a covalent bond. So we say compounds that contain a polyatomic ion contain both ionic and covalent bonding. Polyatomic ions exist on table E of your reference packet, and you should frequently check there for your list of polyatomic ions to see if they're in a compound. Here's some more examples. Ca3PO4. This contains the PO4 3- ion. So this contains both ionic and covalent bonding. NH4NO3 contains two polyatomic ions, the NH4+ and the NO3-. This contains both ionic and covalent bonding as well. This is a little tricky. This is a polyatomic ion, but we're not showing it bonded to anything else. So this is just going to exhibit covalent bonding. If it was present with another ion, like Na+, then it would exhibit both ionic and covalent bonding. For now, just look for a polyatomic ion along with something else to know that it exhibits both ionic and covalent bonding. In the next video, we'll talk about how you write in these charges. SO3 is a tricky one. At first, you might think it's the same thing as SO3 2-. However, it's not, and we're going to get into that a little bit in the next video. For now, we're just going to call SO3 covalent because it's not a polyatomic ion. If it was a polyatomic ion, it would either have to have the charge shown like this, or be with another metal, such as Na2, to show that it's a polyatomic ion. This is one of the most challenging parts of working with polyatomic ions, and we'll talk about that more in a future video. That's all for now. See you soon.